Imagine you're on a cosmic treasure hunt and stumble upon a neutron star. These mind-blowing objects are like nothing we've ever seen before. They pack more mass than the sun into a teeny-tiny space, held together by an intense gravitational pull. Now let's travel to the nearest one and see what secrets this stellar wonder might reveal. Buckle up because we've just got an intergalactic neighbor. Literally, a neutron star has crash-landed next to Earth, and get ready for the wildest ride ever. In this mind-bending video, we're diving into the incredible effects of having one of these cosmic powerhouses right in our backyard. Let's take a closer look at what would happen if this neutron star got uncomfortably close to our home planet. Because when it comes to apocalyptic scenarios, space has some real curveballs in store for us. In today's video, we're exploring the jaw-dropping consequences and a few other doomsday situations that might just have you questioning the safety of our cosmic neighborhood. Get ready for an intense crash course on neutron stars, these tiny titans of the universe. First off, imagine a star so dense that it's almost impossible to wrap your head around its size. A neutron star is born from a supernova explosion, compressing the matter into a teeny-weeny ball, roughly 12 miles across, yet weighing as much as our sun. Mind blown, right? This cosmic marvel is essentially a giant nucleus made up of trillions and trillions of neutrons, packed so tightly together they'd make even the most skilled packer jealous. On its surface, there's just a whisper-thin layer of regular atoms, electrons, iron, and a smidgen of atmosphere. That's it. Let's dive into some jaw-dropping stats on these cosmic powerhouses. Neutron stars squeeze an incredible 1.4 times the mass of our sun into a tiny radius. That's just about 6.2 miles across, smaller than many mountains on Earth. There are currently around 2,000 neutron stars we've spotted in the Milky Way and Magellanic Clouds, but scientists believe there are up to 1 billion of these stellar giants lurking out there. However, most of them have been around for so long that they're super cool and barely emit any radiation, making them extremely hard to detect, even with our powerful Hubble Space Telescope peering deep into the universe. Let's talk about our nearest neighbor among these stellar titans, RxJ1856, 53,754, located an astonishing 400 light-years away in the beautiful constellation of Corona Australis. To put that into perspective, the distance between Earth and Pluto is roughly 5.5 light-hours, so we're looking at an unfathomable gap. Now, imagine if this tiny but massive neutron star were hurtling towards us. But what if we dared to imagine this unimaginable scenario? Keep in mind the chances of RxJ1856, 53,750, zooming our way are extremely low, making it tough to predict with precision. So, let's focus on the potential impact, based on what scientists already know. When a neutron star's immense mass enters your neighborhood, and I mean your solar system, the results would be catastrophic, sending shockwaves that rewrite the rules of our cosmic dance. Imagine the pandemonium, every planet, including our home Earth, being yanked out of its cozy orbit. That's not all. Asteroids and other space objects would also get swept up in this cosmic maelstrom. They'd either be hurled into deep space or crash into each other, creating a destructive chain reaction. As if things weren't bad enough, our planet might end up too far from the sun, pushed beyond its habitable zone. The consequences: temperatures plummeting, and guess what? All that water on Earth would turn into ice. Buckle up, a new ice age is coming, but this one would be off the charts. With temperatures at an all-time low and frozen water covering everything, our planet would become a frozen wasteland. Unfortunately for us, it's not just the environment that'd suffer. Many species, including humans, would face extinction. But hold on, there's more. In a shocking twist, the neutron star could actually give Earth an unexpected shove towards the sun instead of away from it. Can you imagine? Imagine a world where global warming gets a deadly boost. Picture a catastrophic drought, crops withering away, and devastating fires ravaging our planet. The once majestic glaciers and oceans would melt into oblivion as water turns to vapor in an unprecedented heat wave. This doomsday scenario could play out over generations, forcing people to endure unimaginable hardship or, worse still, unfold at lightning speed, leaving us scorched and lifeless under the intense sun. In this desolate future, nothing but tiny specks of dust and gases would be left of Earth. A lifeless, barren rock devoid of the beauty it once was. And just when we thought things couldn't get worse, asteroids in altered orbits could be hurtling towards us, threatening to unleash another catastrophic attack on our already devastated planet. Which apocalyptic vision gets you thinking? Let's dive into Earth's ultimate doomsday scenarios. Would you prefer our home planet turned into a frozen wasteland, scorched by intense heat, or battered to oblivion by an extraterrestrial bombardment? Just like back when those massive dinosaurs roamed, we'd face destruction on a colossal scale, meteors slamming down, unleashing volcanic fires that engulf the Earth and monstrous tsunamis that reshape our landscape. But there's more. The universe has some extreme surprises waiting for us, including neutron stars with gravitational forces so strong they warp space itself. And if we ever got too close, their pull could be disastrous. A neutron star packs an incredible punch. Its gravity is so intense that it could essentially squash anything in its path into a flat, two-dimensional mess, and scientists wonder if life, if it existed there, would adapt to exist in just those terms. But that's not all. These stars also generate magnetic fields that are millions of times more powerful than our Earth's. And if you were unfortunate enough to find yourself within a mere 1,000 kilometers or 620 miles from one of these cosmic giants, your body could literally disintegrate under its grasp. The magnetic force would rearrange the very atoms in your being, turning you into something entirely unrecognizable. Let's talk about neutron stars coming too close to home. If one were headed straight for our planet, it'd trigger a mind-bending effect known as spaghettification. That's right, this isn't just a fancy pasta dish. It's what happens when extreme gravity stretches objects vertically and horizontally like they're made of dough. The neutron star would pull Earth and the Moon apart, stretching them out into long, thin strands, much like a strand of spaghetti. Once our planet and Moon are in that shape, the neutron star could just engulf us. No need for a fork or sauce. It's more like a cosmic vacuum cleaner sucking up everything in its path. So we've established that a neutron star's spaghettification would make for one hell of an unhappy ending for any planet in its path. But it doesn't have to get that close to wreak havoc. Even if it passes by at a safe-ish distance, Earth could still meet its doom. The intense gravitational force would rip us apart like a rag doll, tearing our atmosphere away and leaving no air or life support. This would be instant extinction for all living things on our planet within just minutes. But that's not even the worst-case scenario we're dealing with here. There are more cosmic dangers waiting in the shadows. You might think you've heard enough about what makes a neutron star deadly. And yeah, its gravity is no joke, but there's another player in this cosmic danger zone: magnetic force. Now imagine an extreme version of a magnetar, where the magnetic field is a whopping 1,000 times stronger than your average pulsar. These intense fields can suddenly change shape, unleashing powerful flashes similar to solar flares, only way more potent. This magnetic mayhem originates from the neutron star's crust, making it a force to be reckoned with in the universe. Get ready for an astronomical earthquake. We're talking about a starquake. The crust of a neutron star is as hard as can be and squished by gravity so much it's almost impossible to crack. But when it does, buckle up. This seismic shock causes a colossal flash of radiation that shoots out into space. Think of it like this: imagine your typical earthquake sending seismic waves through the ground. Now multiply that energy by billions. That's what happens in a starquake, and it's as mind-blowing as it is intense. On December 27, 2004, scientists witnessed an astronomical spectacle when a gamma-ray flash exploded from the Magnetar SGR 1000, 800 and 620, and this star is no local neighbor. By the way, it's about 50,000 light-years away. In a blistering 0.2 seconds, this energy blast released as much power as our sun generates over an astonishing 300,000 years. To put that into perspective, in the gamma range, its brightness was so intense that it outshone a full moon. And here's what's even crazier: on that night, the flash ionized the atmosphere to levels normally seen during daytime, basically turning the evening sky into a cosmic daytime. The SGR 1000, 800 and 620 gamma-ray flash holds the title of the galaxy's second largest burst, just after supernova SN 6604. If this powerful magnetar had been our galactic neighbor, let's say, only about 10 light-years away, the effects would have been catastrophic for Earth. This colossal energy release could have completely wiped out our planet's ozone layer. leaving us vulnerable to harmful solar radiation. To put its destructive power into perspective, it'd be equivalent to a nuclear explosion of around 12 kilotons going off right next door. Now, picture this same kind of blast happening to a neutron star within our own cosmic backyard in the solar system. Imagine if this energy burst was heading straight for our cosmic neighborhood, game over for Earth, and potentially the entire solar system. But here's the thing, we might not even have time to sound the alarm. The outcome largely depends on the neutron star's mass, a relatively lighter one, and we'd be lucky enough to dodge this interstellar bullet. A more massive one, and it's an extinction-level event guarantee. A neutron superstar takes center stage. The more massive, the more destructive its potential impact. Picture this, an incredibly heavy one could not only take out our planets, but also pull in our own star, the Sun, sucking it into a galactic vortex. And if that's not wild enough, there's another possibility: our Sun and the neutron star might actually merge, forming a stunning binary star system. Talk about an astronomical twist of fate. But here's the catch, it wouldn't be a 50-50 partnership. The neutron superstar would dominate, steadily siphoning off gas from our Sun until it transforms into what scientists call a donor star. And as for how this cosmic dance might affect Earth, let's just say it's anyone's guess. Binary stars remain one of the biggest mysteries in the universe. Now, imagine our Sun teaming up with this neutron star. It's likely Earth's climate would go into overdrive. With both celestial bodies shining down on us at once, we'd lose that precious night time and get used to a perpetual day-lit world. Not only that, but we'd also face the impact of double the UV radiation and increased solar flares. And if you thought our sky was stunning now, just wait, it would be a whole new breathtaking view with two suns setting on the horizon. So, picture this, our familiar yellow sun replaced by a duo with a neutron star joining in the cosmic light show. Instead of one dramatic sunset, we'd witness an extraordinary double act as two suns dip below the horizon. Thanks for tuning in to this mind-blowing topic. And don't forget to hit that thumbs up